moved to the University of Georgia and is a research associate looking at gopher tortoise use of pine plantations. Ray Igley, a professor at MSU, was another principal investigator on this project, and he is also on the line with us today. Take it away, Rachel. Rachel?
Yes.
You're on.
Okay, thank you. I wanted to let everyone know how we kind of got here to this project. This project stemmed out of a conversation with a group interested in open pine conservation. And one of their questions was how do we reach the target acreage for open pine habitat? One of the thoughts that came out of that conversation was that if we limit ourselves to just those lands managed primarily for threatened and endangered species or other conservation focuses, we're going to have a really hard time meeting those acreage targets. So we need to look at some other sources of open pine habitat. Forest lands managed for economic return is one of those that we need to be looking at. We know that many open pine species inhabit these forests, but we do not know to what extent forest management promotes or does not promote those species, and for how long those activities have an effect on our open pine species. So today we're going to look at three objectives. We're going to evaluate the extent to which managed pine systems can provide open pine conditions, and open pine conditions are going to be described by structural conditions, biodiversity, and open pine focal species. We'll look first at the structural conditions, and then we'll get to the more wildlife-centric focuses. When we researched structural conditions, we started with a review of all the literature that we could get our hands on. And our search criteria were managed loblolly pine in the coastal plain, and the study needed to report something about the stand structure, be it basal area, canopy coverage, percent of mid-story hardwoods or shrubs, and what the herbaceous understory looked like. We took all of this data that we found in our literature review and we started computing summary statistics. And what we found was that there was certainly a shift in conditions from canopy closure to immediately after thinning, and differences between stands that had been thinned only and stands that had been thinned and received a treatment of fire or herbicide. And so here I want to point out some of the variation that we've found in the data, because I think this variation is very interesting, particularly when we get to the mid-story and understory. In the mid-story, for example, if you look at the post-thinning column 1 to 4 years after a thin, we found that the percent of mid-story hardwood could range from anywhere from 9 to 24%. And we got those numbers from 6 studies done in the coastal plain. And similarly, when we looked at mid-rotation management, that ranged from 0 to 22%, also from 6 studies. When we looked at mid-story shrub, for instance, it ranged from 9 to 59% at canopy closure, 6 to 59% after a thin, and 4 to 18% after mid-rotation management. And so that really highlights the importance of fire and herbicide in reducing the mid-story shrub. Similarly, when we look at herbaceous understory, we found ranges of 16 to 61% at canopy closure, 24 to 97% after a thin, and 83 to 98% after mid-rotation management, again highlighting the importance of both thinning and subsequent treatments of fire and herbicide to get this kind of forest structure that we think of as. Looking more closely at the herbaceous understory, we see some changes in the different growth forms on the ground. We looked at grimace, ferns, and forbs, our vines, and our woody species. And we see that Graminoids make up a very low percentage during canopy closure, but certainly increase after thinning and mid-rotation management. We see something similar with the herbs, but we see the opposite with our woody species, that they're in high abundance during closed canopy. They decreased after thinning, and they increase again in the absence of mid-rotation management. Following these summary statistics, we wanted to do a landscape scale analysis. And here we used a program called HabPlan to do a simulation. These simulations take into account different rules governing, how soon a stand can be clear-cut if an adjacent stand has also been clear-cut. It looks at everything in a spatial context. So we looked at two different landscapes within the Gulf Coastal Plains and Ozarks. One was in the East Gulf Coastal Plain, and another was in the West Gulf Coastal Plain. And we did these simulations for 90 years. The first 30-year was a training period to make sure that all of the stands were meeting the requirements for our simulation prior to taking summary statistics. And we generated two types of outputs. One was timber yield, to make sure that we're meeting the economic and operational objectives of these managed pine stands. And the other was basal area, to assess how open these stands were and therefore how suitable they were for open pine species. We then created an open pine index, and we did this by taking 5-year snapshots over the 60 years we used of the simulation, so year 31 through 90. And we classified these snapshots as being non-pine, which was mostly hardwood SMZs, early rotation, and then they could be in open pine, they could be fair to poor condition, which is at least 100 square feet per acre basal area. They could be in good condition, which is 85 to 100 square feet per acre basal area, or in excellent condition, which is at least less than 85 square feet per acre. We had two very obvious sources of variation, site index and planting density. We looked at 4 different planting densities. These range from 350 trees per acre to 700 trees per acre. We're trying to capture the full range of what might be out there on a landscape. So we then did a literature review of pine lands and pine woodlands in the Gulf Coastal Plain, just to fact check our open pine index, making sure that our fair to poor, good, and excellent is matching up with the historic pine woodlands that would have been in this area. We found that we were right on the money. That pine woodlands in the Gulf Coastal Plain were historically up to 85 square feet per acre if they were maintained with fire. And that we did have appropriate mid-story and understory conditions post-thinning. We also looked at a sister project to us that is using some rapid assessment metrics to define open pine condition in several different habitat types, and one of them is dry and mesic hilly pine woodlands, which was developed specifically for loblolly and shortleaf pine that would be a little bit more removed from the edge of the coast and where our landscapes would be. So we compared our index to those metrics, and again we found that we were right on the money. So when we look at the effects of planting density and site index, what we really want to know is how these two things affect how long open pine condition stays on the ground. So this is a figure showing how many years we have in excellent open pine condition following a thin. So here you see if we have a planting density of 350 trees per acre with a stand at 54 site index, we could have up to 4 years of excellent open pine condition. Whereas at 700 trees per acre and 87 site index, we have only 1 year of excellent open pine condition. So here it is for our 2 landscapes. This is the percent of managed pine in excellent condition when stands have been thinned but have not received any mid-rotation management. So there's certainly a larger percentage of managed pine in excellent condition in the lower planting densities, and that's hovering at around 15%, and that goes down to about 5% once you get to 700 trees per acre. You'll see a difference between our 2 landscapes, the East Gulf Coastal Plain in blue and the West Gulf Coastal Plain in orange. And this, I think, stems from differences in site index between these 2 landscapes. The West Gulf Coastal Plain had much, much higher site indices. They were typically in the 70s and 80s, whereas over in the east, they were more in the 50s and 60s. And when I manipulated other simulations to make those site indices equal, I found that they had the same outputs. So I do think it's the site index that's driving that change. We wanted to look at specifically how gopher tortoises were doing on a landscape scale in open pine. And so we did a similar process in this HabPlan simulation, but we adjusted the open pine index to be a gopher tortoise index. And so we backed that up with a literature review. We looked at 98 publications and our index based on the moderate to very high use forages present during stand establishment and immediately after thinning. We also found that there were greater burrow densities and recent clear cuts along right-of-ways and forest edges. So in our landscape analysis, we adjusted that open pine index to a habitat suitability index for gopher tortoises. And these range from 1 being the least suitable to 4 being the most suitable. We found that there is a pretty even flow of high and medium habitats, and that high and medium habitat was highly connected both spatially and temporally. We also looked at the Euclidean distances between suitable stands, and based on our literature review, we think that the Euclidean distance is not so great that tortoises can't keep up with shifting habitat conditions. So if one stand is suitable this year, in 4 years it may not be suitable, but there is an adjacent suitable stand that is close enough to that tortoise that the tortoise can successfully move to the new suitable stand before becoming trapped in unsuitable conditions. One caveat to this micro-study is that we did not have soil series information, and so we had to assume that all soils and all of our pine stands would be suitable for gopher tortoise burrowing, and that may or may not be the case, but that's the assumption we had to work with. The data came from timber companies, and that was scrubbed of all proprietary information, so we couldn't match up stands with soil maps, unfortunately. The next 2 objectives we'll move on to is biodiversity and open pine focal species. For our biodiversity segment of the study, we again did a literature review and what's called a modern meta-analysis. We kept our search criteria to managed loblolly pine in the coastal plain, but instead of looking for statistics on the forest structure, we looked for statistics on a biodiversity response to different management actions. And response can be diversity or abundance data, and we were interested in 6 taxa: plants, birds, amphibians, reptiles, small mammals, and a general invertebrate category. The treatments we were interested in were fire, herbicide, thinning, and stand establishment. We actually looked at 5 different intensities of stand establishment. These ranged from a chemical site preparation with a banded herbicide the following year to a site preparation that was chemical and mechanical with 2 years of broadcast herbicide. So we tried to capture a lot of variation. So we took all of this literature and we took the data from all of these studies to do what's called a modern meta-analysis. Typically within a single study, you'll have between 4 and 6 replicates. And the number of replicates is very influential in how big or small a difference you can detect between treatments. In modern meta-analysis, we take all the data from all the studies we can get our hands on, and instead of having 4 to 6 replicates, we end up having dozens of replicates. And so we can detect very small differences that might not be detected in smaller studies. For the purposes of our meta-analysis, we used the untreated stand as the control for estimating effects of thinning, fire, and herbicide. We used a mechanical site preparation as the control for our stand establishment part of this study. Here we're looking at bird abundance response to a stand establishment. Here I have things labeled numerically and with a description of what that number stands for. Number 1 is the least intensive. That's a chemical site preparation with 1 year of banded herbicide. Number 5 is the combination of chemical and mechanical site preparation with broadcast herbicide sprayed twice. So to read this figure, and you'll see several of them, we're going to say that the purple lines that do not touch the vertical black line are significant. Those purple lines that are to the right of the black line are a positive effect, and those purple lines that are to the left of the black line show a negative response. So in this case, I would say bird abundance increases in response to a chemical plus band stand establishment treatment, but decrease in response to a combination plus band, a combination plus a broadcast herbicide for 1 or 2 years. Here we see responses to thinning by a few of our taxa, and we see that none of our taxa had a negative response to thinning. Reptile abundance and small mammal diversity in particular responded very positively to thinning. Amphibian abundance did have a positive response to thinning, but I want to point out the very wide range of variation in that response, which tells us that there are certainly species benefiting from thinning, but there are also many amphibian species that may be moving on to other stands that are more shaded, perhaps they're wetter, or have ponds that they can take advantage of. So I think we're seeing here a change in the demographics of the amphibian community. Here, we're going to go through responses to mid-rotation management. Plant diversity increased in response to fire and slightly decreased in response to herbicide. The combination of fire and herbicide didn't seem to have much of an effect. This all treatments line really doesn't have meaning unless you look at the landscape scale. And this is if we average the response for all 3 treatments, fire, herbicide, and their combination, we see that plant diversity is basically neutral if you had a landscape where all 3 of those treatments were being used. So it's just barely neutral. It's certainly leaning towards the positive effect side. When I look at bird abundance, they didn't have a response to fire or herbicide in isolation, but they had a positive response to the combination of fire and herbicide, although there is still quite a bit of spread in those numbers. Here we see amphibian diversity, and it is the opposite of our bird response. Fire and herbicide in isolation had a negative effect, but when we looked at the combination of those two, it had there was a neutral response in amphibian diversity. And we can certainly discuss that after the talk as to reasons why that might be. But I think it may have something to do with the amphibian species that are present in the stands in the studies that we looked at. Our third objective focuses on the open pine focal species. While there are many open pine focal species across several taxa listed by the Gulf Coastal Plains LCC, we could only find data on the birds that are on that list. Several studies have before noted community composition shifts after thinning, fire, and herbicide. Singleton et al. 2013 is one of those studies. And what they're noticing is that after thinning, you're seeing a shift from forest interior to more open pine species. And so we wanted to document this empirically, and what we found is that indeed there is a slight increase in focal species abundance after fire and herbicide, and there's also an increase in focal species abundance after chemical site preparation. However, we still don't know what the thresholds are for these species. The LCC Integrated Science Agenda is a good starting point, but we still need to refine what these thresholds might be, and I also suspect that the thresholds will be different depending on which open pine species we're looking at. Prairie warblers, for instance, are shrub nesters. They need a strong shrub component in the mid-story, but there are many other open pine focal species that require very low levels of mid-story shrub component. So there certainly isn't a one-size-fits-all here, and that is evident from the work done by Connor et al. And Nordman et al., who were sister projects also dealing with open pine. I think you can find their talks and final reports on the LCC website if you're interested in further information on those. So let's summarize the biodiversity and focal species part. When we look at fire and herbicide, what we see is that the response is really dependent on your taxon of interest. But for focal species in general, they're going to have a positive response to mid-rotation management. Thinning elicits a positive or neutral response across the board. Stand establishment overall had a negative response, but that's because we included some very, very intensive stand establishment methods. Birds and focal species had a positive response to chemical site preparation, and it wasn't until we were hitting that combination of chemical and mechanical site preparation and those broadcast herbicides that we started to see those negative responses. I also need to point out that the studies we looked at generally looked at responses for 3 to 4 years. So for any of these treatments, we have to remember that these responses are temporary in order to keep focal species in stands. We would need to apply fire or herbicide probably more than once. And on the flip side, after stand establishment, there's certainly going to be some loss of species diversity and abundance, but they rebound in about 3 years. So none of this is permanent. This is the last slide I'll leave you with. This is a picture of a thinned stand subsequently treated with fire and herbicide. This was part of Ray Igle's dissertation work, actually. You can see that this is kind of the quintessential open pine woodland. You have nice spacing between trees, you have minimal mid-story, you have obviously a very herbaceous understory. And this just goes to show that commercially managed pine stands can meet open pine structural conditions and can serve open pine wildlife. But again, we have to be on the ball with mid-story or mid-rotation management to keep these stands in open pine condition long enough for wildlife species to really take advantage of them. And I'll open it up for questions.
Thanks a lot, Rachel. Right now, what we'd like to do is encourage everybody, if you have questions, to please submit them in the question box. And then Rachel has said that in the past, we'd like to encourage some discussion. And so if someone enters a question and she starts answering it, and then you have something to follow on to that specific discussion, you can use the little raise your hand icon in the attendee box, and we'll kind of handle it that way, and we can unmute people and you can ask your questions. And in the meantime, I'd like to ask Toby to go ahead and start launching. We have some questions for you to find out a little bit more about our audience and what you think of these results.
Okay, Greg, and good job, Rachel. That was very clear, some complicated material there, and I think you did a good job presenting it. We've got some questions to ask our audience. I'm going to launch the first poll here and give you about a minute for the responses to come in. So we have about 77% have voted after the first minute. I'll give you a few more seconds to answer this question where you describe your profession. And everybody get them in now. I'm about to close it. 5 seconds. And should we share the results or just go on to the next question?
No, I think go ahead and share the results.
Looks like most of the audience is in the profession of a forest manager or a conservation planner. A few scientists and consulting commercial foresters. And now let's hide that so I can launch the next one. Which of these studies' results are of greatest concern to you regarding your forest management or research? If you don't see an appropriate response, then it's a good opportunity to put a question in the chat box. We've had about a minute there, and we're about at 80% response here. I'm about to close this poll. And it appears that the majority are concerned about this research in terms of vegetation management. 2 more questions. Has the study provided sufficient actionable information to consider changes to your current forest or research plot management?
And I just wanted to let people know that we're going to have a follow-up question to this. If you answer no, we're going to ask for your feedback. And unfortunately, we don't have the option of giving you a short answer, which is what we would have preferred. So we had to kind of come up with some multiple choices in case you said no. That's our last question.
I think we have one more.
Right, the one coming up. And it's an explanation if they say no to this one.
Oh, okay. Okay, so we're going to give you another second or two on this one. Again, we got about 80% response, and it breaks out about into thirds. And then the follow-up to that. What else would be needed? And it looks like we're going to close this one, and half of those are saying additional detail on specific practices, which is not surprising.
Okay, thanks a lot, Toby. We have a good number of questions that have been entered into the question box now. And Rachel, can you see those questions?
No, I can't.
Okay, that's fine. What I'm going to do is I'm just going to unmute people individually and let them go. So Christine Evans submitted the first question. Christine, are you there?
Hey, it's Christine. I just wanted to give Rachel an opportunity to talk a little bit more about the HabPlan landscape analysis and how economic return for net revenue was incorporated into that analysis. And Rachel, you want to speak a little bit about that?
Sure, Christine. That's a good point. When we were doing that analysis, we wanted to make sure that these pine stands met economic and operational goals. So the operational side was pretty easy because the stands were already in acreage that was suitable for harvesting. So you're not looking at 1 or 2 or 3 acres. You're looking at 20 acres at a time for each stand. For the economic side, we constrained the simulation in 2 ways. One was that we allowed harvesting, the final harvest, between 25 and 32 years of age. And we allowed the simulation to choose which year based on a evenness goal for between years. We did not want that to exceed, I think it was 6% for how much timber we're harvesting from one year to the next. And at the same time, we wanted to be as close to 32 years as possible so that we're getting as much timber as we can out of each stand for each rotation. So balancing those two objectives ensured that we were meeting the economic side for commercial forestry.
Okay, the next person that submitted a question was Joshua Skidmore. And I'm going to try and unmute Joshua. Joshua, are you there? Joshua? Okay, well, I'm going to go ahead and read his question. He said, any plans to tie this research into a financial analysis and recommendations for pine management schemes? Is the question. Pine prices are low. Any additional costs in burning and herbicide eat away at profit rather quickly. Thinning is becoming hard to do as well, and we are looking at more natural regeneration, longer rotations, and lower SP costs as a fix.
The current financial market did not play a role in our simulation, but we did conduct our simulation more towards saw timber rather than pulp, trying to get at those longer rotations. I completely understand where you're coming from on wanting cheaper site prep and having those longer rotations, but we tried not to, we're doing the simulation for 90 years, so we're trying not to base all of the decision making on what's happening in the market right now. We tried to generalize it enough so that it might have application on a landscape scale, for many decades to come. But we didn't look at current financial situation. I don't think any of our sister projects did either. So that's certainly a hole that can be filled with future research.
Okay, thanks, Rachel. The next question is from Mike Oliver, and I'm going to try unmuting him. Mike, are you there? Mike? Okay, well, I'm going to read his question then. He says, for vegetation management, let me see, this is not really a question. It just says for vegetation management that also covers my interest in TNE species. I guess he was referring to the question before that you just answered. Does that require a response, Rachel?
I don't know.
I don't think so. Okay, so let's go to, he said we might need some discussion on fire versus chemicals.
Yeah, fire is great, but there are plenty of places where fire just can't happen between wildland and urban interface, smoke regulations, restrictions on how much you can burn in a season and some lawsuit happy people. There's a lot of barriers to effectively burning. So sometimes we've got to use chemicals, and we also need to understand that there are some differences between fire and chemicals, and each has its own pros and cons. I don't think using all fire or all chemicals is the answer. We use what we can where we can.
Okay, thanks. And then Greg Wathen has a question next. Greg, are you there?
Can you hear me?
Yes.
Okay. Yeah, thanks, Rachel. Great presentation. My question had to do with the best way to get this research information into the hands of industrial forest managers. Is that through extension? Is it through news publications? What do you think about getting this out to folks?
I think presentations and word of mouth is a great tool. We had two of our co-authors who are in industrial forest management, and they can certainly be instrumental to word out to their respective organizations. I think going to conferences like SAF can be useful, but you know, when I think about what we do in academia, and that is publishing in academic journals, I don't think that is a great way of targeting this audience. I think we would be better suited by doing a more newsletter type publication or a white paper, something no more than 3 pages that lays everything out there. Is fairly quick and easy to read, but gives enough depth of information that foresters can make good decisions. Does that answer your question?
Yeah. Do you think foresters would be open to using this information in terms of making some changes to their management?
I hope so. I think if we can show them that it also meets their economic and operational goals, in addition to having positive impacts to biodiversity, sustainability, some conservation goals, then I think we'll get buy-in. But we've got to show that they can still cover all their costs while doing conservation.
All right. Okay. Thank you.
Welcome.
Okay, the next question is from Chuck Hunter, and I'm going to see if I can get him. Chuck?
Yes, can you hear me?
You can go ahead and ask your question.
Yes, 2 questions. The first one was on the planting densities, and this may be more relevant to long-term management of longleaf pine. It may be with shorter rotation plantation type management, but I was curious with the lower densities that may be beneficial to gopher tortoise and other grass ground cover species, whether there were long-term consequences in the stand management that would make it more difficult to manage broken pine species later in the stand life. Again, that may be more an issue with longleaf, but I'm just wondering if there were an assessment of longer-term consequences of lower stocking.
Okay, so let me make sure I understand you correctly. You want to know how those lower planting densities early on in the rotation have effects for focal species, endangered species like gopher tortoise, and whether there is a positive or negative effect later on in the stand's life once we're approaching final harvest? Okay. Okay.
Right, beyond gopher tortoise with red cockaded woodpecker.
Sure.
Other species.
All right. When we did our gopher tortoise analysis, we did find that stands planted at lower densities not only were in that excellent open pine condition for gopher tortoises. Between planting and canopy closure, they had more years there, but they also had more years in suitable habitat condition from thinning to final harvest. So that initial planting and density does have effects that carry through the entire life of the stand. And it really limits the canopy closure, in the middle of the stand's life and at the end of a stand's life, just prior to clear cutting. So it's important at both ends. I didn't find any negative effects for wildlife by having those lower planting densities. However, that 350 trees per acre, we used more to incorporate the very lowest densities that might be out there and targeted more towards longleaf pine. the 435 and 530 trees per acre would be more typical of the loblolly management that we're seeing. The 700 trees per acre, which had hardly any open pine condition, we're seeing as really more of a thing of the past. It's not what a lot of the timber companies are using right now. But we just wanted to show you the full gamut, if you will, of what could be out there. But the 400, well, hang on a second, the 435 trees per acre was still pretty close to 350. Those two were running pretty neck and neck as far as open pine index and gopher tortoise habitat suitability. So that could be a way of, loblolly pine, still having great economics, but also meeting conservation goals at that lower end of the planting density scheme. But go on, you had a follow-up?
Yeah, and again, I think it's mostly evidence from longleaf pine that stands have been planted at the lowest end of 350, so really have some difficulty growing the types of longleaf that we want in the long term for red cockaded woodpecker trees and so forth, and maybe more difficult in carrying fire if the needle cast is not extensive over the area, things like that. So those are kinds of things that we have seen discussed, that the really low value or low stocking may have negative long-term consequences while having some short-term benefits.
Right, and I think there are a lot of edaphic factors that we have to take into consideration too. Like you're saying, with having enough needle casts to carry a fire, there are some stands that planted at a higher density than 350 that still don't have enough needle casts to really carry fire through the stand. So I think that's got to be a site-by-site decision, and you just got to know your site well enough to estimate how many trees you need to have that good carriage of fire. And there's also going to be effects of temporary weather patterns and some of our larger scale climatic patterns like El Nino, La Nina. So all that has to be taken into consideration.
Yep, makes sense. Thank you.
Thank you.
Okay, we're kind of coming to the end of our hour here, and we have one final question, and it's from David Bryan. And David, you're unmuted. Are you there?
Yes. Am I on?
Yes.
Yes, I can hear you.
Okay. So I'm from Virginia. Work within RCS in the game department here. Increasingly, it seems like in Virginia, as far as the management on young stands, the forestry community is getting away from site preparation burning, and most everything is being done either by chemical release, where they plant and then come back a couple growing seasons later and spray over the top, or the most popular now is doing the heavy-duty site prep spraying, where basically the spray all sorts of pre-emergent as well as post-emergent chemicals, basically create the moonscape look, and then go in and plant. And there's been some ongoing debates and friendly debates between a lot of the biologists and foresters on, as far as on a long-term, until canopy closure of those pines, is there any better or worse method that you've seen as far as biological response?
Well, in the literature, I'm also seeing those shifts that you're talking about. So studies published in the 80s and 90s did have those site preparation burns, but studies since 2000 very seldom have them. So what you're seeing on the ground is certainly reflected in the research that's being conducted, first of all. Secondly, when I look at the data and think about the different species responses, birds had a pretty positive response to chemical site prep, and plants and small mammals had about a neutral response. But as you got into the chemical and mechanical dual site preparation, that's where numbers really started to fall off, especially for small mammals. And again, using the broadcast rather than the banded herbicide also resulted in decreases in abundance of small mammals and plants. And those effects tended to last 3 to 4 years. I think the banded herbicide had rebounded small mammal species sooner than a broadcast herbicide. But that's just, what I'm seeing from the most current studies that are out here.
That's interesting. I mean, again, most of our post-planting herbicide work tends to be by helicopter on large tracts. And it sounds like what you're saying is it seems like doing the site preparation spraying up front may be the better way to go from a biological side as opposed to spraying over the top after planting.
I think so, and that's what the data is telling us.
Okay. Thanks so much.
You're welcome. One more thought on the site preparation side of drawing in open pine species to these freshly planted stands is the importance of snags or other perches in adjacent stands. One thing that I observed is that cavity nesters were the only group of birds that had absolutely no response to any type of site preparation. Their numbers stayed constant, whether it was the least intensive to the most intensive, whereas it was your ground and shrub nesting birds that fell off the most quickly as stand establishment increased, and it was your birds nesting near the tops of trees that had a more gradual falling out as stand establishment increased. But we found that snags and other perches in the surrounding area can help alleviate that falling off that we saw.
Well, thank you very much, Rachel, for a really illuminating presentation. And I have to apologize to everyone because for some reason the system is not allowing me to upload the documents that I wanted to provide to you. So in the follow-up email to everyone who attended, I will provide a link where you can go and download both the final reports for this project as well as the certificate from SAF if you're interested in applying for credit. And I appreciate everybody who took the time to attend today. We appreciate it. Thanks very much.
Thanks, everybody.